In this video, which is the continuation of the first video, I will be giving examples on how Ore's theorem will be solved. So let's start by looking at this graph. First, we will label it. So this is vertex A, vertex B, vertex C, vertex D, vertex E, vertex F. First, again, we will, as I said from the previous video, we will count the number of vertices in the graph. So number of vertices will be 1, 2, 3, 4, 5, 6. So 6. Now, difference between Ore's theorem and Dirac's theorem is that Ore's theorem deals with the non-adjacent pairs. So the sum of non-adjacent pairs. So we'll be doing it. So first, so for A, what's the non-adjacent for A? F and C, because A is connected to D, A is connected to E, and A is connected to B. So we can say B, E, and D are adjacent to A. So the non-adjacent to A are F and C. So let's AF, A plus C. So we will total the number of degree for letter A. Letter A, 1, 2, 3. For letter F, 1, 2, 3. C, for A, 3 also. For C, how many? 1, 2, 3. So also 3. So the total number of vertices of non-adjacent pairs for AF and AC are both 6. So next, let's go to letter B. So what are the non-adjacent for letter B? The non-adjacent for letter B are E and D. E again, E and D. Why? Okay, the adjacent vertices for B are A, C, and F. So vertices E and D are not adjacent to vertex B rather. So we'll count. So next we will count the number of degree of we will find the sum of the non-adjacent for B and E. How many degree for letter B? 3 also. For letter E, 1, 2, 3, 3 also. This gives us 6. For B and D, 1, 2, 3, 3 plus another 3, which gives us also 6. Next, we will find the non-adjacent for letter C. We have seen A is 1, so we will find another non-adjacent pair. So the non-adjacent pair is letter E. A and C and A plus C and C plus A are just the same. The sum will be the same. So we don't have C plus C here or E plus C, so we will include C plus E. So how many degree for C? 3 also. E, 3 gives us 6. Next, D. Are there no non-adjacent pair for letter C? So let's move on to letter D. Non-adjacent pair of letter D aside from B, F. Okay, this D is adjacent to A, D is adjacent to D is adjacent to A, D is adjacent to C, D is adjacent to E, but non-adjacent to B and F. We already have value of B and D, so only D and F will be written, so or will be typed. So D and F Number of vertices for D, 3. For F, also 3. Gives us 6. Next, let's go to letter E has E, B, and EC. They're already written. So these are the sum of AF, AC, BE, BD, CE, CF, DF rather, which have a sum which is a sum of 6. So what we're going to do, let's look back at the Ore's theorem. So the Ore's theorem states that if a simple graph G has n greater than 3 vertices, such that the sum of degrees of every pair of non-adjacent vertices is greater than n, then G are greater than or equal to n, then G is Hamiltonian. Again, every pair. So let's compare. We know that the number all are the sum of the non-adjacent are 6. So is 6 greater than or equal to 6? Yes. So it means this graph is Hamiltonian circuit. This graph is Hamiltonian circuit. And also this graph can be solved by Ore's theorem. How about if the graph is not applicable to Ore's theorem, will it still be a Hamiltonian circuit? So that's the second example. Okay, this is the second example. The vertices are already labeled, so let's count the total number of vertices. So number of vertices in the graph would be 1, 2, 3, 4, 5, 5. So for next is to know the non-adjacent pair. So let's start with A. What is the non-adjacent pair for A? It would be D and C. A plus C. A plus D, because then the adjacent pair of A, the adjacent pairs of the adjacent vertices of A are E and B. The non-adjacent vertices are D and C. So A plus D or D plus A. Okay. So what is the number of what is the degree of A? 2. Degree of D? 2, which gives us 4. For C, or C plus A, 2 plus 2 gives us 4. So next, let's go to letter B. What are the non-adjacent vertices of B? These are D and E. So B and D, or D plus B. Next, or EB and E, or E and B. Okay. Let's look at D. How many what is the degree for B? 2 plus for D also 2. So gives us 4. This one is also 4. Next, let's look at letter C. C plus, we already have C plus A. We'll look at the other non-adjacent pair, which is letter E. Okay. For C, 2 again. For E, 2 gives us 4 also. Lastly, for letter D. What is the non-adjacent pair for letter D? Oh, we already have the non-adjacent pair for letter D. Okay. So now we have to check the condition of by using Ore's theorem. So all of them are have the sum of 4. So we'll is 4 greater than or equal to 5? No. So this circuit cannot be solved. The graph cannot be solved by Ore's theorem. But is this graph a Hamiltonian circuit? Let's check. So let's start here. Let's start at E. Let's start at E. Let's start at vertex E rather. So I can go to A or D, but I'll choose letter D. So this one will be our 1. From D to C, 2. From C to B, 3. From B to A, 4. And lastly, from A to E. So we already as seen from the graph, we ended where we started. So this graph is a Hamiltonian circuit. Right? So the purpose of Ore's theorem is to sufficiently prove that the graph is a Hamiltonian circuit. This ends the tutorial about Dirac's and Ore's theorem, as well as with Euler and Hamiltonian path and circuit. Hope you understand the lesson. Thank you.